Hi, my name's Nick Myrie, and this is a protocol presentation video for the class ITD 1223 Network Systems for the semester of Fall 20. And I'll be going over the protocol ICMP version 4. So let's get started. So what is ICMP version 4? It's the Internet Control Message Protocol, and it's used for performing tests and reporting errors on the IP protocol. And that's actually the IP version 4 protocol. There's ICMP version 6 and ICMP version 4, and each have their associated ICMP version for each protocol. Anyways, what this allows to happen is the IP devices can send control messages to other IP devices and those control messages are used by other protocols to sort of fix problems sometimes. And it operates on the network layer of the OSI model, and it's primarily a message passing service where messages are used by other protocols, like I said before. And so let's go over a little bit about the history. ICMP version 4 was introduced in 1981 in the Request for Comments 777. It was defined by John Postel, who was an internet founder. And it's had some revisions since then, and the current definition is located in the Request for Comments 792 and was published by the Internet Engineering Task Force. So the operation of ICMPv4, it works in conjunction with IP version 4 to report network issues. So like if an error happens, it'll send a error message or something like that. So it sends error messages to the source of the original message from the IPv4 rather than the destination. So the person that sent, or the device that sent the data and the error happened, it would send the error message back to who was trying to send the data. And there's several reasons for errors, like routing problems, time to live, dropping to zero, fragmented data, other things like that. It provides some feedback even if UDP is used, and UDP is basically it just means the data gets sent without checking for errors on the level 4 of the OSI model. But what it essentially does is just that it reports errors and signals to other protocols and devices for problems. It's necessary because IPv4 just kind of sends the data. It doesn't check for errors or whatever. It just concerns itself with sending the data and getting it to the destination. So ICMP is kind of there to flag things when things aren't going smoothly and other things like that. And the reason it operates on the network layer is so it can actually travel on the network, so it's routable and can get back to the source destination. And ICMP doesn't send error message every time an error occurs, because if the initial error caused another error for the next ICMP packet and it just keeps looping like that, that'll prevent loops on the network from happening, which could cause a ton of congestion and is not good. So what the actual messages look like, they have a type field, a code field, a checksum, rest of the header, and then a data section. And the type field identifies whether it's for errors or queries, and queries are just for testing or IP related features, just gathering information. Code byte is sort of a subtype to the type field, it's like the reason for the error or the query, and the rest of the header section is usually dependent on the message type. The data section usually just contains the data for the packet. So starting with error messages, ICMPv4 only reports errors, it doesn't correct them. It relies on other features to do that because it's primarily a messaging service. It sends errors to the source of the corresponding datagram, which is the data that gets sent by IPv4. So, and it doesn't send error messages for failed ICMP messages or special addresses. This is helps prevent the infinite looping and other problems. Several types of error reporting messages. There's destination unreachable, source quench, time exceeded, parameter problems, and redirection. So 5 types total. And destination unreachable, it just means that it wasn't able to reach where it was wanting to go. There's a ton of reasons. I'll go over the reasons here in a minute. Source quench, which is actually deprecated now. It was deprecated in 2012, but it was originally meant to signal that there was too much congestion on the network, so it would just discard the message. Destination unreachable also would discard the message. Time exceeded means the time to live reached 0, or all of the data fragments weren't received in time and the message was discarded. And time to live is just how many hops it goes from one router to the next. So if you have 5 hops, it can only go hop from to 5 routers total, and after that 5th router it'll just drop the message. Parameter problems. Parameter problems, it means there's a problem with the message header and the message was discarded. It could be ambiguity, or some bits got moved around and it doesn't really know what's going on. Redirection, it just means that it needs to be sent somewhere else. This is the only one where the message isn't discarded. It's actually just rerouted to where it thinks it needs to go. Okay, so for the destination unreachable error codes, code 0 means network unreachable, so it means hardware failure. There's just a ton of these codes. Code 6 has no information regarding the host on the network. It's just real super useful stuff for identifying what could possibly be the issue of why the data didn't get sent or something like that. And then the rest of them, there's only a couple for time exceeded, parameter problem, and redirection. There's only 2 for time exceeded. That says when this time to live field, for code 0, it says when this time to live field reaches 0, the router discards the datagram and sends a time exceeded error message to the originating source of the datagram. And code 1 is if the data doesn't receive all the fragments. So that's useful for identifying different kinds of problems. And then parameter problem defines there's ambiguity in the header field, like I said before, where there's a problem. Code 1 just defines that there's something missing there that should be there. Redirection just basically codes for telling it where it needs to go. But for the source quench error message, you only get one message. It doesn't send very much data back, but it's deprecated now, so not a big deal. Okay, so for query messages, they're used to identify network problems. There were initially 5 types of messages, but 3 have been deprecated. The deprecated messages included router advertisement, solicitation, address mask, request, reply. There are 2 types currently, echo request and reply. This is pretty commonly used for ping, and timestamp, request, and reply. What echo request and reply does is it's used to confirm that 2 hosts can communicate with each other. Ping is a popular type. The type field 8 is request, and the type field is 0 when you want to reply. Timestamp request and reply is used to calculate the round trip time for a datagram to travel between 2 hosts. It's also used for synchronizing clocks between hosts. So, and for this one, the type field is 13 when you want to request, and the type field is 14 when you want to reply. Popular tools that use ICMP, traceroute is one. It basically just traces the route to get to the destination, router by router. So each hop it has to take, it will send a packet back letting it know it got there. And then there's ping, which is pretty commonly known. It's used to test basic connectivity. It tests round trip time between source and destination. It's a lot more compact than traceroute. It just associates itself with the destination and the source. And it doesn't actually use a port number since it operates at a lower level than the transport layer. Path ping is basically just a mashup between traceroute and ping. It's not as good as either one because you have to have something enabled on it that can cause a lot of problems. So it's not as resilient as either of them. And an example of how ping is used for connectivity, like say you have a problem, you can't reach the internet or something. You can just ping the internet and see if you have connectivity. And there's actually 2 ways to do this. You can do it from the internet to the host or from the host to the internet. But if so for this example, if you want to go from the internet to the host, if you ping the internet and there isn't connectivity, that means there's a problem between the internet and your PC. And then you can ping your router and your PC, and that would mean if you don't have connectivity, then that means there's a problem between your router and your PC. And if you ping, then you would ping your host IP address to test your hardware. If that's functioning correctly, it means your router has a problem. But if it's not, you ping your loopback address, and then that would indicate something's wrong with the software if it still didn't get connectivity. And then, yeah, so that's a good way for identifying a problem with networking. There's several exploits using the ICMPv4 protocol. Smurf attacks, ping floods, ping of death. Basically, these are all just ways to send a lot of pings to the victim, and they're effectively distributed denial of service attacks that just overwhelm the host and cause a lot of problems for the victim. ICMP tunnel, this one just tricks the host into thinking it's an ICMP packet when it's actually something else. Twinge attack is basically like the other 3. It sends a lot of pings to the victim. Okay, so between ICMPv4 is actually the older one. ICMPv6 is intended to replace it, and ICMPv6 comes with more features and functionality. It actually replaces ARP and handles router discovery when the version 4 couldn't do that. Anyways, that has been my presentation on ICMP version 4. Thank you for watching, and I hope you have a good rest of your